We're going to look at some examples of problems where we have to use a quadratic model. We're going to use quadratic functions to model a function that relates to some kind of a real-world problem that we want to solve and interpret. So a toy rocket is launched vertically upward from a 12-foot platform with an initial velocity of 128 feet per second. Okay? Its height h at time t seconds after the launch is given by this quadratic function, right? How long will it take the rocket to reach the ground? Okay? So what do you think? How am I going to use that quadratic model to answer that question? Say it again. Factor out a -4? I mean, we might be able to do some stuff like that, but first I guess we need to set up an equation that's going to, like that's typically with this kind of thing, we want to set up some kind of an equation that we can solve to answer a specific question. And what's the specific question here? How long will it take the rocket to reach the ground? Well, reach the ground. How is that significant with this quadratic function? 0, right? Isn't reach the ground, that's a height of what? 0, right? Okay, so what that's telling us is h equals 0, right? So I could take this quadratic model, and if I set h equal to 0, that's just going to give me the equation -16t squared plus 128t plus 12 equals 0, right? Now, by solving that equation, I'm solving for what variable? What are my solutions going to be? For t, right? Well, what does t stand for? Time in seconds after it's launched. Well, that's what we want to know, right? We want to know what's the value of t when the height is equal to 0. Okay? Everybody get that? So we're done with kind of the physics part of it now. I mean, like that's physics. We just set up, we set up a model here. Now we can kind of shift gears. We can shift into algebra mode and just put our heads down and go to work and solve an equation. And when we're done, we might have to like pick our heads back up and say, okay, like what does this all mean? But right now we're just solving that thing. So suggestions. Okay, Grace had a good idea. Why don't we factor out what in this case? Okay, and in fact, why not even divide by 4? -4, perfect, right? Because we want to have the coefficient of x squared, so t squared in this case. We'd like that to be positive when we're solving the quadratic equation, right? And we're just solving it now. So what if we divide each side through by -4? Okay, what's that going to give us? Well, what's my first term going to be? 4t squared minus 32t minus 3 equals 0. Okay. How would I solve that one now? Quadratic formula. We could certainly do quadratic formula. Could we use slip and slide on this if we wanted to? I doubt it. It's not worth probably messing with anyway, even if we could, right? You can always check, because the first step of slip and slide, I'm going to slip the 4 to the other end, and I'm going to get a -12. My magic numbers would have to multiply to -12 and add to -32. Good luck. That's not going to happen, is it? Right? So we're just going to need to use quadratic formula. Or we could complete the square, but probably just quadratic formula. Okay? So let's do that. If we solve with the quadratic formula, what values am I plugging in? What are A, B, and C? 4, negative 32, negative 3. Okay, so what goes here then? What's my first? 32, good, because I get negative B plus or minus square root. Negative 32 squared is the same as 32 squared. And what is that going to be? 1204? Is that what you got? Okay, 1204 minus 4 times negative 3. Well, look what happened. I get a negative times a negative, so that's positive, right?
Oh, no.
That's wrong? Okay.
Yeah.
Okay, what should it be? 1024. Okay. Okay. And then that's all going to be over 2 times 4, so it's all over 8. Everybody agree? Okay, so I get 32 plus or minus square root of, we're going to get 1024 plus 48 is going to be 1072 over 8. And we probably want this, I would guess in this case that they're probably just wanting these like rounded to the nearest something or other. Okay? I mean, I'm sure we could simplify that square root. We know 4 is going to go into, 8's going to go into it. Well, say it again. Does 16? I know 8 does. 16 might. Oh, it is 67 times 16. Okay, so 1072. If we do a little factor tree, we get 16 times 67. So I get a couple of 4s in a single 67. Okay. So we get then t equals 32 plus or minus 4 times the square root of 67 all over 8. If I simplify both of those, 32 over 8 is 4. 4 over 8 is 1/2, so I get 4 plus or minus square root of 67 over 2. Does that all make sense? If I split the denominator and reduce. Okay, give me 1 to 5 on that. Are we good with that last step? Okay. 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 Okay, so square root. So let's turn those into decimals, how about? Because probably decimals, I mean, that doesn't mean much to us in terms of, how many seconds is that? I don't know. We want it in terms of decimals probably. So if we turn those into decimals, what are my two values here? T is approximately equal to this, or T is approximately equal to that. What is 4 plus the square root of 67 over 2, somebody? Square root of 67 over 2 is going to be, square root of 67 is going to be like 8.1-ish, right? Something pretty close to 8.1, I bet. What is it? I mean, 4 plus that is going to be about 8.1. Somebody help me out here. What'd you get? What is it again? Say it again. Somebody doing it? Oh, right here? Aubrey is? Yeah, 4 plus the square root of 67, the square root of 67 over 2. About 8.1, I bet.
Yeah. Well, the square root of 67 is 8.1. I don't know about the rest of it.
Well, so divided by 2, So it's, see, I mean, just, how about the whole thing? So square root of 67 over 2 plus 4. So it's going to be about 8.05-ish. Okay. 0.9. What was the next digit? 2.6. So 0.93. There's one answer, right? If I do 4 minus the square root of 67 over 9, it's going to be negative 0.093. Okay? So then, which one of those is the answer we're probably looking for? The positive one, right? Doesn't that make sense? So we can just discard that negative one. What are the math gods doing? They gave us a negative. Okay, the negative one actually has some meaning. It really does have some meaning. The negative one, could we interpret that? It's not the answer we want, but could we interpret it? So it's saying that the rocket reaches the ground at either positive 8 point blah, 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 or negative 0.093 seconds. How would that make sense? That's it. That's how long it would have taken if the rocket had been launched from ground level instead of 12 feet. That's how long it would have taken the rocket to rise up from ground level to the 12-foot platform where it was launched in this equation, right? So it really does have some physical meaning, right? And what is a negative time? Does negative time exist? Sure it does. I'll prove it to you right now. I'm going to snap my fingers, okay? First time I snap my fingers, go. 1001, 1002, 1003. When I snapped my fingers the second time, the first snap happened at negative 3 seconds because it was 3 seconds before the second snap. That's negative time. No big deal. Okay? Make sense? So that's how we interpret that. Negative means it was just before the launch is all. Okay? All right. Kind of cool, huh? Give me 1 to 5. How we doing? Good? Okay, all right. Okay. Well, we'll do some more of them. This stuff, it gets easier the more you do. So how about this one? One leg of a right triangle is exactly twice as long as the other. The hypotenuse is 4 centimeters longer than the longest leg. What are the lengths of all 3 sides? So we need to build a right triangle. Okay, and we want to find the lengths of all those sides. Well, how could I turn this stuff into some information that I could use to populate my drawing? I need to put some variables in there, right, or a variable in there. So let's see, we've got one leg of a right triangle is exactly twice as long as the other. 2x, and what would the other one be then? X. So the legs would be x and 2x, okay? And then how about this? The hypotenuse is 4 centimeters longer than the longest leg. 2x plus 4. Okay, now how am I going to come up with the value of x here? Do I have some relationship between the sides of a right triangle? A squared plus b squared equals c squared, which means that leg squared plus leg squared equals hypotenuse squared, right? Okay, so we've got the quadratic equation then. X squared plus 2x squared equals what squared? Equals what? See, I think I heard it. What else? What's going to be squared here? 2x plus 4, yeah, right? Leg squared plus leg squared equals hypotenuse squared. Okay, so all I've got to do then is just simplify that and try to solve for x. So x squared, what's this going to give me? Well, I get x squared plus, what's the quantity 2x squared? 4x squared, right? How about over here? If I FOIL that out, what am I going to get? 2x plus 4 squared. I can use the, you guys remember this pattern? If I square out a plus b, what's the result? Do you remember? A squared plus 2ab plus b squared. We haven't talked about that one yet this year. We'll review it, but maybe remember that from the past. Even if you don't, that's okay. We could always just do, you could also just FOIL out 2x plus 4 times 2x plus 4, right? Either way, I'm going to get the same answer. So if we use a squared plus b squared equals a squared, so that's going to give me 2x squared plus 2ab, 2 times 2x times 4, plus b squared is 4 squared. Okay, everybody good? Okay, so then we end up with x squared plus 4x squared equals 4x squared plus 4x times 4 is 16x plus 16. Okay, well look, we've got a little bit of cancellation. I could subtract 4x squared from both sides. I'll push everything over to the left side and put this in standard form, right? Everybody good so far? Okay. Any red flags here? Anybody need me to redo any of that? Okay. So all we did here, like this part right here is probably the part people aren't sure about, right? What did I do here? That whole thing right there. All I did was I just squared that out. I used this pattern, but I didn't have to. We could just do it this way. We could just say 2x plus 4 squared is 2x plus 4 times 2x plus 4, right? And I could just FOIL. I could just distribute the 2x, and that's going to give me 2x times 2x is 4x squared. 2x times 4 is 8x. Distribute the 4. 4 times 2x is 8x. 4 times 4 is 16. Isn't that part right there just a 16x? Right? So 4x squared plus 16x plus 16, right there. Okay? If you do it that way. Okay, does that make sense? Okay, and then that's what's on this side of the equation because we just squared out the red expression. The other side was just x squared plus 4x squared, right? So then when I simplify the entire equation, I could subtract 4x squared from both sides, so those go away. I'm going to subtract the 16x over there and the 16, and I get x squared minus 16x minus 16 equals 0. Okay? Good? Question?
So why did you square the initial equation?
Okay, because of the Pythagorean Theorem. Because we know that if I've got a right triangle, leg squared plus leg squared always equals hypotenuse squared. Okay? Just only because it's a right triangle. Okay? Okay? So now we can't factor that conveniently. There are no numbers that conveniently multiply to negative 16 and add to negative 16. So we're going to have to use quadratic formula on this. So we get x equals negative b plus or minus square root negative 16 squared is 256 minus 4 times 1 times negative 16 all divided by 2. Well, negative times negative is positive. So I'm going to get, I'm going to get 64 plus 256 is 320. Yeah, right, 320, square root of 320. 16 plus or minus square root of 320 over 2. If we take our 320, that's going to break up into, is that 60? That's 64 times 5. No, it's not. Is it? Yeah, it is. Okay. So 64 gives me a couple 8s. And I got a single 5, right? So I'm getting x equals 16 plus or minus 8 times the square root of 5 all over 2. So it's equal to, if I split my fractions up, I'm getting 8 plus or minus 4 times the square root of 5. Well, 4 times the square root of 5, is that bigger or less than 8? Bigger. You're right. How do we know? Is the square root of 5 greater than 2, isn't it? Because square root of 4 is 2, so square root of 5 must be bigger. Good thinking, right? So I know I'm subtracting a number bigger than 8. So 8 minus 4 radical 5 gives me a negative answer. Does that make sense in our triangle? No, because we can't have negative lengths of sides on a triangle, can we? Distance in this case always has to be positive. So we could cancel the negative answer is non-physical, right? That one doesn't work geometrically. So we've only got the positive one. And so we end up with the solution then, x equals 8 plus 4 times the square root of 5. But that's just the mathematical solution. Now we've got to go back to the original problem and apply that to the problem to get the solutions, the geometric solutions, right? So what does that mean then? Well, we're just going to plug those values, that value of x, in for each of these side lengths, right? So what does this side length become? Well, this one's going to become, what was that again? 8 plus 4 radical 5. I'm going to write that down up here. So then that means that that's the length of this side right there, isn't it? Right? This guy is 8. If we make our triangle, this side is 8 plus 4 times the square. That's supposed to be a 5. That's a bad 5. 4 times the square root of 5. This one down here is 2 times that big. So it's going to be 16 plus 8 times the square root of 5. And then this one is 4 more than that side, so it's going to be 20 plus 8 times the square root of 5. Okay? Give me 1 to 5 on that. Is that all making sense? Okay? Okay? All right, let's look at maybe one more example here. I'm going to pick another one that's good. That one's all right. I want to pick one. That would be good. Oh, that's a pretty good one. Let's do that one. Okay? So they're telling us here, these are kind of cool. These are like SAT kind of questions a little bit. Yeah, I mean, this is kind of stuff. So as you're getting ready for SATs this spring, these are, no, for you guys it won't be, it'll be next spring, won't it? Yeah. You got it this spring. Yeah, there you go. Okay, so it's going to be, you'll be doing PSATs, right? But SATs will be next year. I mean, this is not a really difficult one, but this is one that you could see on there. You know, the SAT is not, like, you don't have to do any calculus on it. It only goes up through pre-calculus. It only goes up through trig, really, and that's it, right? So you guys you'll be in a good place. Next spring, you will be covering trig, so you're going to be in a great place to be able to, you know, really be prepared to do well on the math part of the SAT. Okay, but this is a classic kind of a problem you might see, something like this, where you're having to interpret a situation. The math is not very difficult, but understanding how it applies is kind of the part that takes a little practice. So what about this? The area of the shaded region is 59. Okay. The shaded region, so that's the darker region, is 59. What are the dimensions of the outside rectangle then? Okay, how could I come up with, I've got to be able to solve for x to know, don't I? Would everybody agree I need to know what x is so I can plug it in? Give me thumbs on that concept. Does that make sense? Okay, so to know what x is, I have to come up with an equation that I could solve for x, right? Ideas? I know the shaded region is 59. Could you come up with an expression for just the shaded region? Yeah, I could subtract the inside area from the outside, from the entire rectangle, from the big rectangle. Does that make sense? Subtract the area of the small rectangle from the big rectangle, and that gives you the area of the shaded region, doesn't it? Agreed? So what would that look like then? So that's going to look like the big rectangle is going to have area what? Trey, what's the area of the big rectangle going to be in terms of x? How would I find it? Well, you have to multiply it all out. Just what times what? There you go. So that dimension times that dimension. Good. So the big area, whoops. Would be 2x minus 1 times x plus 6 minus the small area would be what? What's the small area? X times x plus 3 equals what? 59. So that's really no big deal. Now I just have to simplify that, solve for x, and plug it in, right? No big deal. So if I FOIL all this out, what am I going to get? If I distribute the 2x, I'm going to get 2x squared plus 12x. Distribute the negative 1, I'm going to get a minus x minus 6. Agreed? Okay. Minus the quantity x squared plus 3x, right? Subtracting the whole thing. Everybody agree? Okay, equals 59. Okay, well that gives me 2x squared plus 11x minus 6 minus x squared minus 3x equals 59. Let's just combine like terms. So combine the x squareds. X squared plus 11x minus 3x is plus 8x. Combine all the constants. So negative 6. I'll subtract the 59 to this side, and I get minus 65. Equals 0. Good? Okay, that's just quadratic formula stuff, right? Can I factor it? Are there numbers that multiply to negative 65 and add to 8? Maybe. Yeah, 5 and 13. It would, wouldn't it? I can factor that. 13 and negative 5, is that right? Multiply to negative 65 and add to 8? That works, doesn't it? That's right, isn't it? Yeah, that's right. Would you agree? So what are my solutions then? X equals negative 13, good. Or x equals 5. Now we could try both of those. Or is one of those going to be a little fishy? What do you think? Can we disqualify one of those? Yeah, what's wrong with the negative 13? Yeah, that's going to give me negative side lengths, which again we can't have, right? Doesn't make any sense geometrically. So we could cross this guy out, and we know that 5 is the answer then. 5 is the one that's going to work. Well, if I plug 5 back in, what's that going to give me? 5 plus 6 is 11. 2 times 5 is 10 minus 1 is 9, right? Yeah. So it's 11 by 9. And what do they want to know? The area? Is that what they want to know, or they want to know the dimensions? Dimensions, yeah. So 11 by 9. Okay? Make sense? Give me 1 to 5 on that guy. How we doing? Okay, good. Good. Let's see, what else? Do I have any other really good ones here? That's pretty similar to the one we just did. We can probably skip that. When are we out of here? 45. Okay, let's at least just kind of set this one up. We don't have to do the whole thing. These get kind of redundant, right? They're just solving a bunch of quadratic equations. What's a rectangular prism? Just a box, exactly. It's just a box. So if we draw a rectangular prism, okay, what's it tell us here? It tells us the height is 3. The length and width are x minus 1 and x plus 4. If the volume is 198, how could I set up an equation? Yeah, right. So the volume of a right rectangular prism is just length times width times height, right? Is how I get volume. Just multiply the dimensions. So I just get x minus 1 times x plus 4 times 3 equals 198, right? Expand it out, set it in standard form, solve the equation, done. Okay? I think I'm done. I think you guys can work a little bit. Okay? Boy, that went faster, much faster than anticipated. Wow, that was good. So tomorrow, I have a review built. You can decide how to use it. I've got it all, flip chart all built up. Maybe what I'll do tomorrow, how's this sound? How about if I put it up and I go through the problems and you guys give me thumbs up or thumbs down on if you want to do them? That sound good? And then that'll kind of be our review for the test.